Okay, so just a quick finish up here for yesterday's homework questions. We were asked, a couple people asked these questions, and we cut the first one short, and I got hung up on the second one. We'll sort of see why in both cases. Um, so question 13 was basically solve this question. Very nice question. At the end, we were asked to find the spot where this expression was greater than 4,000. And I said basically the reason you got hung up was it's just too long and messy a problem. And the intent here was to graph it to find the solution. So I think I have here somewhere. Here's the graph from that last question. And I've zoomed in a lot, zoomed up a lot, kind of moved around, and got to the point where I've got the top part of this graph. If I did zoom out, you'd see it's just, well, obviously it's very tall. I'm at 4,000 here. With this Desmos program, I kind of like this one better than most of the others. None of them are perfect, but this one seems to be better than most. Scrolling to this point was a pain, so it's not perfect that way, but it's still, like I said, not bad overall. If I graph the 4,000, so the question was, where are we greater than 4,000? What happens with this program, when we have points of intersection, if we click on them, they do show up. And so this is 7.19 and 4,000. This is 5 and 4,000. And this is 27.8 and 4,000 approximately. And so those become the points at which we hit the 4,000. Obviously, between these values is where we're above 4,000. And then anything beyond the 27.8, in theory, is above that 4,000 as well. What you want to remember, though, with this question is we're talking about this box. So it's no longer just a basic equation, it's a theoretically a real world problem. And so what we found there was if we cut off between 5 and 7.2 centimeters from every corner, we end up with a volume over 4,000. That seems pretty reasonable. If we cut off 27.8 or 27.8 centimeters from each corner, then in theory it's saying we're going to end up with over 4,000 square centimeters as well. But of course, if we cut off 27.8 going, well, either direction, quite frankly, we run out of box. And so we end up with just a chopped up box that is all theoretical at that point as well. Okay, so our answers here, I don't think I ever wrote them down, but was basically between 5 and, so 5 is less than or equal to x, or is less than x, sorry, is less than 7.2. So anything in that range cut off from the corners gives us that 4,000 square centimeter, or sorry, cubic centimeter box. Now I said I would also do this algebraically just to show that it's possible. It got to be pretty ugly, not impossible for sure. I think we could all probably get through it, but time-wise it certainly wasn't going to be a good use of our time in class. So this is the equation we started with, greater than the 4,000. I expanded it out. Along the way I probably skipped a few steps here and there, but basically, if you wanted to test it and check it out, you could do it in a couple more steps, or if you're comfortable with the steps I did, obviously that's fine as well. So I've just multiplied through, subtract the 4,000 to the left, and then common factor of 4 just to sort of deal with some smaller numbers, divide that out, and we need to then factor what's left over, which is the x cubed minus 40x squared plus 375x minus 1,000. A little bit of a cheat. Because I had already graphed it, I knew that the 5 would work, and so tested the 5 theoretically here. And big surprise, it worked. Synthetic division to simplify it further. And the second, the bracket that needs to be factored further is this one. I don't think there are two numbers that multiply to 200 and add to negative 35. And of course, actually there aren't, because we've already graphed it, so we know. So moving forward then, using the quadratic formula, we can find those same two x values. It seems much quicker going through it this way than it did when I was actually writing it out. And so we end up with this here, 35 plus or minus root 425 over 2. And hey, what a surprise, 27.8 or 7.2 are our two values. Again, the zeros specifically. And so when I make my number line 5, 7.2, 27.8 are the zeros. Looking at the ranges, or sorry, the groups on either side, test a value over here. I tested 0, 0 minus 0 plus 0 minus 1,000 gives me a negative. Tested 6 here, found that I got a positive in there. I tested 10 here and found that I got negative, and tested like a billion out here and found that I got a positive value. But again, we don't want to recognize what this means. This means we're cutting almost 28 centimeters from each side, or from each corner. And that is impossible. Okay, so really not impossible to do the question that way. A little bit messy, obviously, and a little bit long, but still doable. The second question we ran into, Emily asked about what do we do when we have 3 sections to an inequality with x appearing in 2 of the 3 sections. I stared at it for a moment, I mumbled some things, and I said, I give up, I quit, I'm leaving, I don't know what I'm doing, and I started to cry. Kind of a stupid thing for me to do. I mean, not the crying made perfect sense, but to try to make up a question and sort of see if it fit the question that we had been asked in the homework. When I went back, I found 2 questions that looked like that. The first one was in 6B here. I guess there's a couple here. 6D as well. 6D actually has 3 x's in it, but the same sort of idea. 6B has 2 parts, 2 x's, and 3 sections. But what we want to recognize is what the question is asking us to do. It says, for the following inequalities, determine if 0 is a number in the solution set. So really what it's asking is, if I put 0 in for the various x's in any one of the questions, does the statement hold true? Sorry, that's kind of annoying of me. So if I'm looking at 6b, it says plug a 0 in here, plug a 0 in here. Hopefully you're seeing those things flash. And I get negative 6 times 0 is 0. 0 plus 4 is 4. And I have a 12 on the end. And the question really is 0 less than 4, which is also, and in turn, less than 12? And of course, yes. And so if you did check the solution set, I think the solutions are on this one. If they aren't, I apologize. But the answer is simply yes, it does fit. You know, in A, you plug a 0 in here, plug a 0 in here, and you get 0 less than or equal to 1. Yes, that is true. For D, put a 0 here, 0 here, 0 here. I get 0 less than or equal to 1, less than or equal to negative 1. So D is not true. So those ones, that's all you were asked to do. In 7, you'll notice I don't think any of them have 2 x's, and so they just become, very similar to the ones we did already. The only other question that kind of looked like that, 10 had multiple x's in it. Again, a little different wording though. It wasn't sort of solve it. It was which one of these makes sense, which one has a solution. And if we look at them, I'll go through them fairly quickly. I have an x, a minus x, and an x. And so if I'm simplifying this, my first instinct is to subtract the x. And I end up with this in the first set, sorry. X is subtracted out, minus 2x here. I want to isolate the x, so I'll subtract the 3. I get negative 6 is less than negative 2x, which is less than negative 8, subtracting 3 from all three parts. And then if I divide everything through by the negative 2, remember that if we divide by the negative, we flip the signs. So we have positive 3 is less than positive x is less than positive 4. And hopefully you recognize that cannot be the case, because this is saying that 3 is bigger than x and x is bigger than 4 at the same time, which in fact is saying that 3 is bigger than 4. Clearly that's not the case. If we do this other one, again fairly quickly, I'll do exactly the same steps. Subtract the x first. I get negative 3 is less than 3 minus 2x, which is greater than negative 5. Now subtract the 3 again. Negative 6 is greater than negative 2x, which is greater than negative 8. And this time when I divide by the negative 2's, I get positive 3 less than x less than 4, which is absolutely fine. There are values that work there. Okay, so this was just, again, me doing something that somebody as old as I am should know better than to do. Don't make up questions when you're not really sure what they're supposed to look like. If I make up a number or something to factor, it's because I know what I'm looking for. To make up a question kind of without really knowing what we're being asked is just a mistake that I shouldn't make. Okay, so hopefully that helped clear up. The first one was not a doable problem. This one, 10 and 6b, were fine. So I'm going to stop there.